Great to be back for another video of 3 deviations. Welcome back, everybody. In today's video, I want to keep talking about integration by parts, but in this video, we're going to be talking about how we do integration by parts twice. So we talked about how to do integration by parts once, and that was pretty helpful. We talked about an integral with an algebraic and a trig function, the product of those two, as the integration by parts rule is really the product rule, the reverse product rule of integration by parts of our products of functions, right? So in this video, I'd like to expand this where we talk about doing integration by parts 2 times, just like we could do the product rule 2 times, or we could do the substitution rule 2 times, we could do the chain rule 2 times. We can also do integration by parts 2 times. So in today's video, we would like to explore that, and after that, following, we will be talking about a more generalized version that is informally called the Tic-Tac-Toe Method, which is basically doing the integration by parts 3 times, 4 times, however many times you need to do. So let's talk about an example. So today I would like to integrate x squared times e to the x dx. Now, of course, on their own, we know how to integrate both of these functions. Of course, x squared goes to 1/3 x cubed, and e to the x goes to e to the x. But, unfortunately, we're now dealing with a product of 2 functions. So we're going to need to treat this a little bit differently. So let's just recall what the integration by parts rule says. That says that if we want to take the integral of a function u times a function times dv, that's equal to uv minus the integral of v du. And that was our also beloved integration by parts rule. So now let's take a look at tackling this integral here. So let's go through our Lyautey rules. So we have no logarithmic functions, so L is out. We have no inverse trig functions, so I is out. We do have an algebraic function, x squared, so A is in. So we should choose x squared to be our u. And, well, in Lyautey, e for exponential is at the end. So e to the x should definitely be our dv. So let's have a look at our bracket. So we're going to set u equal to x squared. That means du becomes 2x dx. dv is going to be equal to e to the x dx, and v will then be e to the x, because when we integrate e to the x, it stays as e to the x. Okay, so now when we plug this in, right, we do u times v, so we do uv, so that's going to be x squared times e to the x. Then we also do v du, so we do this bottom thing here, so that becomes minus the integral of 2x times e to the x dx. Right, so actually what it looks like is we have another product of 2 functions, which of course means that just for this, we are going to need to do another integration by parts. So that's exactly what we're going to do, and it looks like we have an algebraic and an exponential, so let's set 2x equal to, I'm going to call it u prime. Don't confuse that with the derivative of u. We're just going to use this to indicate that it's a different u than this u. Sometimes you could write u sub 1 and u sub 2. I like doing the prime notation. And that means that by process of deduction, then e to the x is going to be our dv prime. And of course, we should be having differentials here and here. Okay, so now we are ready for our next bracket. So u prime is going to be equal to 2x. Differentiate that. That gives du equals 2, and then we add a dx. And then there should be a dx there as well. Can't be forgetful of those. That means dv prime is equal to e to the x dx, and v prime is equal to e to the x. Okay, so now we do the same sort of thing that we did earlier. We're just going to throw this back in so that we don't forget about it. So we're going to be left with x squared minus e to the x minus, now this is the fun part, 2x e to the x minus the integral of 2 e to the x dx. Okay, now this is an integral we can do. We can pull that constant 2 out of the integral, giving us x squared e to the x minus 2x e to the x minus 2 times the integral of e to the x dx. Of course, the integral of e to the x is really one of the simplest integrals that we have in calculus. That's a calculus 1 integral. That's even a unit 4 integral. We know how to do that. So that's going to give us x squared e to the x minus 2x e to the x minus 2e to the x. Can't forget to distribute. then that's going to give us x squared e to the x minus 2x e to the x plus 2 e to the x. And of course, we cannot forget that lovely constant of integration, plus c. So this is our final answer. We can draw a little square there to indicate that that is what we mean when we integrate x squared e to the x dx. In the next video, I would like to talk about the tic-tac-toe method. So let's say that I had something like x to the 5th times e to the x. It is going to be such a bummer. I'm going to be left with u quadruple prime for a 4th integration by parts, and that is not going to be fun. So we have an efficient method called the tic-tac-toe method, and that is basically exploiting the patterns that we see here in these terms that